Hello everybody. Apparently I am still Paolo Peser, thus I welcome you to another episode of GenExpr for musicians. In the previous video we looked at the fourth and also the last of the statements that we saw we can make in GenExpr, the loop statement. Thus, in today's video we will switch topic and we will talk about four specific operators that are very useful when we are writing GenExpr code: the buffer, the data, the history, and the param operators. So let's not lose time and let's dive in. Okay. So, two things that we need to know about those four operators that I mentioned. The first is that they must be declared before the statements that we want to make. And the second is that they share a characteristic, they have a characteristic in common. That is, you need, in order to declare them, you need to write first the name of the operator, not of the instance, but of the operator. So if it is a buffer, buffer, if it is data, data, and so on. And then the name of the specific instance of that specific operator, so that we can refer to it. Now, let's go into the specificities of each of them by starting with buffer. For those that don't have this knowledge, a buffer is a block of memory that holds an array of data. So you might say the buffer operator is a buffer. No, actually the buffer operator is a reference to a buffer that is external to the Gen environment where the buffer operator is, but internal to MaxMSP, so inside a MaxMSP patch. The operator, the buffer operator, is declared as buffer, the name of the buffer, and then in between parentheses, the name of the buffer object in MaxMSP to which the operator is referring to. That can also be changed, the buffer to which the operator is referring to, with a message, such as the name of the instance of the buffer operator, and then the name of the new buffer object to which we want the operator to refer to. We will see this in some minutes when we will get to the code. So instead, let's move on with the history operator, which is a stateful allocation of memory that can act as one sample delay, since its state carries over to the next sample. Do you remember in the first episode when I said that variables cannot carry their state to the start of, actually to even to the next sample? And in order to do that, we will need a specific operator. History is that operator. So now we know how to do that in case we want to carry a value to the next sample. The state of history can be updated within our code whenever by using the name of the specific instance of the history operator as a variable, or by sending to the gen patcher or the gen.codebox till the object a message with the name of the specific instance of the history operator and then the value to which we want to update the operator to. So what is useful the history for? For incrementing data, for updating states, or for creating gates in combination with conditional statements. Thus, it is generally useful for recursion. If you want to make chaos theory attractors, history is the operator that you want to use. Let's move on to the operator param, which is an externally modifiable named parameter that is declared as param, the name of the instance of that specific param, and then in between parentheses the initial value. And whose state can be updated with a message similarly to history that is formatted as the name of the specific instance of the parameter, of the param operator, and then the value to which we want it to be updated to. Okay, now let's look at our code in which I declared a buffer, a history, and then a param with the names chow, count, and add. Then I stated that count is the value of the specific instance of the operator history is updated at every sample by incrementing it by 1 and by the value of add, so the param add. And then I have a conditional statement that says that if count is greater or equal to 48,000, count equals to 0, so it's a reset. And then I state that out1, out2, and out3 are equal to the length of the buffer, the number of channels of the buffer, and then the value of count, the state of count. Okay, so now we see, let's go back to the buffer chow, and we see indeed that the length of the buffer chow is 100 milliseconds, which corresponds to 4,800 samples at 48 kilohertz. So it's correct. And indeed, we also see that the buffer chow has 4 channels, and indeed out2 is 4 channels. So it is correct. If we change it to hello, we see that the number of channels is 3 and the length of the buffer is 20 milliseconds, which corresponds to 960 samples at 48 kilohertz sample rate. Now let's look at count, which is of course making a ramp because it's incrementing by 1 for each sample. So it's doing a ramp at every second at 48 kilohertz sample rate. And let's look at it while I change the initial state of count. And indeed, we see that it never manages to grow because I'm always changing to very low values that if I stop, indeed it will start again. Now we know that count equals to count plus 1 plus add. So if we make a value of add as 10, we will see that the ramp will be much faster because now the incrementation will be much more. And indeed, the ramp is much faster. All right, let's move on to the last operator, which is the data operator, a locally stored array of 64-bit floats. What does it mean locally stored? Locally to the gen environment, to the gen patcher, which means that data doesn't require a buffer object outside the gen patcher. The data operator is declared as data, the name of the specific instance of the data, and then in between parentheses, the length in sample, and after a comma, the number of channels, which must be stated at compile time, so you must write them, are coding them, and cannot dynamically change. Once they are set, that's it. The data operator is gonna have that amount of samples and that amount of channels. So let's look at the code that I prepared, which is very simple. I declare a buffer with the name checkData and a data with the name myData, and then I state that count equals -1. Then I prepare a for loop statement, And in this for loop, I just save the value of count inside my data and then increment it by 0.2. So what I'm expecting is that there is a stairs of values. How do we check that? Well, we can write the values that are inside the data operator myData inside the indexes of the buffer named checkData. And indeed, we do it with another for loop. And if everything went smooth, we should be able to see the stairs of values incrementing. Now I cannot open by double clicking on the buffer so for you to see, but in MaxMSP we have a very neat object which is called waveform that can be bound to a specific buffer and that will show directly its content. And indeed we see an increment of values in it. So I would say that the first for loop works as expected. Alright, for the video of today, this is it. I hope that everything was clear enough and there are no doubts, but if there are, please leave them down below together with comments and feedbacks. And it was nice to have you for this episode as well, and I hope to see you in the next one. Have a fantastic day. Ciao.